This video is about accessible near-storage computing with FPGAs. My name is Schmid and I'm from the Operating System and Middleware Group from the Hasso Plattner Institute in Germany. Now, despite the predicted end of Moore's law, processors are getting faster and faster. But the system interconnects and memory interfaces are increasingly becoming a bottleneck, especially for big data applications, which have to transfer large data volumes from storage to the main memory of the system to the CPU for processing. And so near-storage computing could be a solution to this problem. Let's take, for example, a database application that has stored a column of values on the SSD. Now, instead of transferring the entire column to the system memory to be filtered and processed, we can perform these filtering and processing operations on the path of data between the SSD and the main memory. And we do that by adding in a coprocessor, in this case an FPGA, which performs the filtering and aggregation operations and then only forwards the final aggregated results to system memory. And our framework MetalFS now provides a very easy to use interface for orchestrating such near storage compute pipelines. And it reuses very familiar operating system concepts such as files for data items. The computation kernels, which we call operators, are represented as executables. And then you can combine files with executables to a near storage compute pipeline using the very familiar pipe and redirection operators from your shell. So for our database example, you can see on the bottom in the terminal window how this would look like using MetalFS. So you see three executables combined here. First of all, there's MetalCat, filter, and then aggregation. And all these three executables are connected to each other using a Unix pipes. MetalCat is only used to refer to the input of the pipeline, which is the column of 64-bit integer values that is on the SSD. The filter operator is configured to only filter out values that are in a specific range. And then the aggregation computes a sum over these filtered values and redirects the final aggregate value to the system memory. Now, the interesting part here is that MetalFS is able to detect that it can combine the three programs, MetalCat, filter, and aggregate, into a single near-storage compute pipeline. So this gives you a very easy-to-use interface to create such near-storage compute pipelines just using the familiar shell syntax. In addition, MetalFS tries to improve the accessibility of near-storage compute in different levels. So, for example, the entire implementation of the framework is in user space, so it can be installed on any unmodified Linux operating system. And then we also provide ready-made Docker-based development environments, which you can use to create your own applications based on MetalFS and to simulate an FPGA with your application. For more information, I'd like to point you towards our documentation on GitHub and also the source code repository. Thanks.